Hey guys, I just spent 21 minutes recording this video and at the end realized that it was not using my document camera or looking at my computer. So here we go. It might go a little quick because I have done this and this is my second time, but I guess I'll get all my bugs and all my mistakes. So there's a few things. There's one thing that I want to talk to you about. Up here, this is the assignment that you guys did yesterday since you're watching this. Look at that. Look at that. It's so awesome. 21 students scored between 80 and 100%. You guys, that makes my heart so happy because the one thing that we're worried about is that you guys don't have us to help you. And of course, we miss you, but you don't have us to help you. But this is super exciting to me. You're getting it, and that's what's awesome about it. Okay, it still looks like 4 of you need to complete this assignment. So complete this assignment, please. All right. So we're going to get with our lesson. So this is for 17.3, assess reasonableness of quotients. I'm going to give you a hint. You may want to take some notes while you watch this video. Okay, this is going to help you. So we're talking about assessing reasonableness. Okay, estimation. Why in the world do we have you estimate? Is it so that we give you more work, more busy work? No, it's so that you can go back. Oh, the reason why I'm not showing my smiling face today is because I've been sick. I've had a cough. See, I'm trying really hard not to cough right now, but I've had a cough. Is that better? I've had a cough and a sore throat, and so I've been banned from the school. So I haven't got ready today. So you'll be able to see my cute face, my smiley, happy face tomorrow at 10 o'clock, maybe today. Anyway, so assessing reasonableness. One of the reasons why we teach you how to do this is so that you can go back and say, is this a reasonable answer? Okay, I've been working with my second grader, and she had some question like 24 minus 9 or something, and she's like 56 or something outrageous. And so I said to her, if you start with 24 apples or 24 anythings and you eat 9 of those apples, are you going to end up with more apples than what you began with? So that's why we teach reasonableness. Okay, that's why we estimate. So, all right, here we go. All righty then. A geologist collects a soil sample that weighs 43 and 5 ounces. The geologist wants to place an equal amount of soil into each jar for separate testing. About how much soil does the geologist place in each jar? Well, there's what we want to find out. Okay, so we have a whole and we're dividing it into groups. Okay, so it says write a division expression for the problem. Well, what's an expression? What's the difference between an expression and an equation? Well, an expression is what we do. It doesn't have the equal sign or the answer. So we're going to start with 43 and 5/10, and we're going to divide it by how many jars we're separating it into. Divided by 6. Okay? All right. So it says rename the dividend as a number of tenths. Okay, so we're just taking this number and we're renaming it as tenths. So we're going to take that and we're going to make it 535 tenths. Okay. Then it says, and adjust it to be a compatible number with 6. Okay, so remember when we're making compatible numbers, we want something that it can be divided by equally. So 6 cannot be divided, or 43 cannot be divided by 6 equally, right? What is a number that can be divided equally? Well, we know that 42 divided by 6 is 7, and it goes in equally, right? But it's not 42, it's 435, so we want to make it 420. So 420 is our compatible number because we know 420 can be divided by 6 equally. Okay, so then it says estimate the quotient, about how much soil is placed in each jar. So we know that it's 420 divided by 6, right? Well, for right now, we're still working with our tenths. Okay, so remember, we divide our non-zero digits first. So 42 divided by 6 is 7, and then we annex our 0. Now, where to place the number? Is this really 420? No, it's tenths. So we know the decimal goes right there because the decimal was still right there. So if we come over here and we do 42 divided by 6, okay, 42 divided by 6 is 7. Bring down the 0, 0. But where does our decimal go? Our decimal goes straight up. So our answer is, that's where our decimal goes. So our answer is 7 ounces. Okay, now let's go see if that's a reasonable number. If I start with 43 ounces and I put them in 6 jars, is 7 pretty reasonable? It is. Well, what if I wouldn't have put that decimal there? 70 ounces. What if I would have said my answer 70 ounces? Well, we started with 43 ounces. Can we add, if we're dividing it here, 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 are we going to end up with more in a jar than what we started with? We're not. And so that's why we do reasonable numbers or reasonableness. All righty then, here we go. The greatest monthly snowfall total in Alaska is 297 and 9 inches. This happened in February 1953. Compare, there's a word that we need to focus on. Compare the daily average snowfall for February 1953 with the average daily snowfall for Alaska's greatest 7-day snowfall. Sorry. Use estimation. Okay, well over here, here's the greatest 7-day snowfall of Alaska. Okay, so right now our number is in for the whole month of February. So we don't want us to know what's the whole month of February. They want us to know a daily number. So we're going to have to divide this by how many days in the month there are. And usually when you say how many days of the month, everybody says 30. So I know it's February, but we're estimating, remember? Okay, so what would be a compatible number? 30 to 29. Well, of course, 30, right? And then we make that 300. So 300 divided by 30 equals, 3 divided by 3 is 1. We divide out this 0 with that 0, and we're left with 1 0. Okay, so in 1953, the average snowfall in a day was 10 inches. Oh my heavens, could you imagine getting 10 inches of snow? We got some snow yesterday. Maybe we'll have some today, but I don't know because it's not today yet. And it wasn't anywhere close to 10 inches, okay? I think we maybe even got an inch. Anyway, 10 inches, that's a lot. Okay, but this is the greatest 7-day snowfall. So this isn't even the greatest. So in Alaska, the greatest is 186 and 9/10 inches, but it's a 7-day snowfall. So what are we going to divide by? We're going to divide by 7. Okay, so what is a compatible number? And remember, you kind of want to go up. So what would this one be? 21 is a compatible number. So I'm going to do 210 divided by 7. Well, 21 divided by 7 equals what? 3, and then we have a 0 still. So 30, 30 inches. Could you imagine getting 30 inches in a day? That would be some insane snow. Okay, so we're coming back and we want to compare the daily average snowfall for February with the daily average snowfall for Alaska's greatest set. So how am I going to figure that out? I want to find the difference, really. So what's 30 minus 10? Well, 20. So the daily average for the month is about, okay, so this one's larger. So we know it's 20 inches less, okay? So the daily is 20 inches less than the 7-day because they asked us first to compare that, okay? All righty then. Here we go, estimate the quotient by using compatible numbers. So here we are again, 8 and 23. So what would be a number close to that can be divided equally? It's 24. So we're going to add that 0 there. So our dividend would be 240. Our divisor is 8. So 24 divided by 8 is what? 3. And then, oh, let me do this so you can see. And then there's a 0 left. Okay, same thing. Oh, look at that, 35. What's a number compatible that can be divided by 7 equally? Oh, 35, we're lucky. So what's our dividend? 350. Our divisor 7, so 35 divided by 7 is 5, and we have a 0. Okay, all right, flip her over. Okay, which number is closest to the actual quotient? All right, here's something that we can we can automatically, there's some that we can automatically cross out. Okay, if we have 4 cookies, because we're taking 4.82 and we're dividing amongst our 7 friends. If I have 4 cookies, can all of my 7 friends get 1 whole cookie? They cannot, right? So automatically, I know my answer is not going to be a whole number. It's going to be a decimal. So I can automatically cross out those 2 numbers because it's not a whole number. Or yeah, because I don't have enough to share amongst my 7 friends. Okay, so if we find compatible numbers, what's a compatible number? 49 and 7. Well, I know that 7 times 7 is 49, and add a 0. Okay, so 49 divided by 7 is 7, and then I have a 0 left over. But I want to, if I did 4.82, this would really be 4.90, right? I want to know where my decimal is. So knock, 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 because Dad's scared. Yes, he goes to get Mom. So we're going to have 2 digits in our quotient. 49 divided by 7 is 7. That's 49. Bring down our 0. 0 divided by 7 is 0. So we're done, all right? And when we divide decimals, where do our decimals go? They go straight up because we are dividing by a whole number. Okay, so there's our answer, 7/10 or 70 hundredths. Good. Okay, Maddie has 3.8 liters of lemonade. She pours the same amount of lemonade into 8 pitchers. Which is closest to the actual number of liters of lemonade that she pours into each pitcher? Okay, again, I have 3 liters. I'm putting it into 8 pitchers. Do I have enough liters to give every one of these pitchers 1 whole liter? I don't. So I know automatically that my answer is not going to be a whole number. So I can automatically cross out those 2 answers. Okay, so 3.8, what's a number compatible? What times what? What's our number? Well, I know that 8 times 5 is 40, and that's close to 38, right? So 40 divided by 8, but it's really 4 divided by 8 because we don't want to ignore that decimal, okay? But 40 divided by 8 is 5. And if I need to find out where the decimal goes, oops, 8. It's 5, 40, and my decimal goes straight up because I divided by a whole number. Okay, so my answer is there. Alrighty then, here we go. A park district buys some sporting equipment for $1,084.56. They agree to make 12 equal payments over 1 year. Is it reasonable that they expect to pay about $100 each month? Well, we want to see, we want to estimate, okay? So we're going to divide this number by 12, right? Because there's 12 equal payments. So what's a number compatible to 12 that's close to 10? Well, it's 12, right? So we are dividing 1,200 divided by 12. So our non-zero digits, 12 divided by 12 equals 1. And I've got 2 zeros left, okay? So 1,200 divided by 12 is 100. So is it reasonable to expect to pay 100 each month? Yes, but then it says to explain, okay? So then we're going to estimate 1,084.56 to $1,200. and 1,200, oh, I don't need to put that, divided by 12 equals $100, okay, for each payment. Great. Okay, here we go. John earns $3 for every package he wraps. To take a package to the post office, John earns 1 65/100 times as much as he earns for wrapping a package. How much will John earn for wrapping a package and taking it to the post office? Now, this is kind of a tricky question. When I first looked at it, I thought, oh, we're just finding out what 3 times 1 65/100 is. Okay, that is not what we're finding out. We have to find out how much John will earn if he wraps the paper package and he takes the package to the post office. Okay, so we know that if he wraps something, he gets $3. But we don't know how much he makes for taking it right now. But it does tell us that he earns 1 65/100 times as much as he earns for wrapping. So we want to find out what 165 times 3 is. Okay, so how do I multiply decimals? I'm going to ignore the decimal first, and then I'll figure out where the decimal goes. 3 times 5 is 15, carry the 1. 3 times 6 is 18, plus 1 is 19, carry the 1. 3 times 1 is 3, plus 1 is 4. Okay, how do I move my decimal? The number of digits behind the decimal, 1, 2. Okay, so what did we just solve? What did we just figure out? We just figured out how much it costs to take it to the post office. He gets $4.95 just to take a package to the post office. But is that what they wanted us to find out? No, they wanted us to find out how much it will cost for the wrapping and taking. So what am I going to do to this number? I'm going to add $3 because we have to wrap it. Okay, so how do I add decimals? I line up my decimals. 5 plus 0 is 5. 9 plus 0 is 9. And 4 plus 3 is 7. Where does my decimal go? It goes straight down because I'm adding and subtracting. So how much does it take to wrap and take it? $7.95. Alrighty then, our last question. Okay, Jordana buys a salad. Oh, a salad would have been really good to have with our dinner tonight. Tonight we had meatballs and mashed potatoes. That salad would have been really good. So Jordana buys a salad at the store for $4.35. How much change does she receive if she pays with a $10 bill? Well, what are we going to do? We're going to subtract, okay? So $10 minus $4.35, okay? So can I take 5 from 0? If I have 0 apples, can I take 5 away? I can't, so I'm going to go next door to my neighbor. Does my neighbor have anything to give us? He sadly doesn't. So I go next door to my next neighbor. Do they have anything to give us? He doesn't. So they go to their next door neighbor. Oh, they have apples to give us. Okay, so now this neighbor's saying, hey, I still need some apples. This neighbor's saying, hey, I still need some apples. Okay, now everybody has apples and we're happy. Okay, 10 minus 5 is 5. 9 minus 3 is 6. 9 minus 4 is 5. And 0 minus 0 is 5. Okay, I'm adding and subtracting decimals. So where does my decimal go? Straight down. So what change would he get? $5.65. Okay, great job. Hopefully, hint, hint, you watched this video first before you did your lesson. And I bet I will be able to tell who watched the video and who didn't. Okay, tomorrow, or hopefully you watched this before, but we're going to do some fun things. I think we'll do some very fun things during our meetups. Okay, and I'll explain it tomorrow. But again, remember why we assess reasonableness is so we can come back and say, does that answer make sense? And if it's an answer that does not make sense, then we did something wrong and we can go back and see where we went wrong. All right, have a good rest of your day, guys. I hope you're getting out and doing fun things, not out, but riding your bike or getting outside and doing some fun things, and enjoying your time being at home. We'll talk to you later.